Let's look at how to find the domain of each of these four functions. Our first function f of x is equal to x squared minus x plus 3. So seeing that x squared, this is what we would call a quadratic function. If you were to look at the graph of this function, it would be a U-shaped graph and extends forever to the left and forever to the right. And so the domain for every quadratic function is going to be all real values, which we can write as negative infinity to positive infinity. So a lot of the functions that we learned about in our toolkit functions will have a domain of all real values. So our constant function, our identity function, our absolute value functions, our quadratic functions, all of those can have any value of x as an input and therefore have a domain of all real values. The two main families of functions that are exceptions to this are functions where we have a variable in the denominator and functions where we have a square root. So as we're taking a look at our function b here, we have 1 over 6x. So the thing that we want to focus in on is the denominator. The denominator cannot be equal to 0. So we cannot have division by 0. So we're actually going to ignore the numerator completely. It makes no difference whether it's a constant or a variable expression. We're only going to look at the denominator, and we just want to make sure it's not equal to 0. So here 6x cannot be equal to 0, or if we divide by 6, x cannot be equal to 0. So oftentimes we'll write our domain in interval notation. So if we want to have every value except for 0, we could write that as negative infinity to 0 with a parenthesis, and then 0 to infinity also with a parenthesis. So this is including every possible value of x other than x equal to 0. So what if we have a larger expression in the denominator? The idea is still the same. Whatever's in the denominator cannot be equal to 0, and we're just going to ignore whatever we see in the numerator. So here we'll say, okay, 3x minus 2 is not allowed to be equal to 0. We want to isolate our x. So adding 2 to both sides, this means that 3x cannot be equal to 2, and dividing x cannot be equal to 2/3. So in the same way, we'll write our domain excluding just this one particular value of x. So you can have anything from negative infinity up to 2/3. The parenthesis shows not equal to 2/3. And then anything starting at 2/3 but not equal to 2/3 forever off to the right or up to positive infinity. Our last type of function here is a square root function. So the stuff that's on the inside cannot be negative. So the square root of a negative number gives us a complex or an imaginary number. So we want to make sure the stuff on the inside is never negative. So mathematically, the way that we can say never negative is to say that x minus 2 must be greater than or equal to 0. So this excludes everything that is negative. So adding 2, we have all the x's that are greater than or equal to 2. So if it helps to picture that on a number line, think about 2 on the number line. So we're saying equal to 2 or greater than 2 would be allowed. So as we go to write that in interval notation, we would start with 2 with a bracket up to infinity. In this case, our square root function just had the square root term. If there were additional terms out in front or behind the square root, we would ignore those as well. So we just look at what's on the inside of the square root and set up an inequality greater than or equal to 0. So kind of the keys to remember is when you're looking out for division by 0, you're going to set it up so that you have an equation where whatever's in the denominator is not equal to 0. If you're working with a square root function, whatever is on the inside of the square root, you'll set up an inequality greater than or equal to 0.